9 years ago a strange green glow was spotted in the sky by a Dutch school teacher as he was hunting for galaxies. The Green Blob, which is 650 million light-years from Earth, lies near a gas bubble in a distant galaxy. Together the pair are providing new evidence for how giant black holes affect their host galaxies. Now researchers have pieced together what causes the blob to glow, revealing the echo of the past activity of a black hole as it grew rapidly. The Green Blob, also known as Hanny's Voorwerp, which is Dutch for Hanny's object, was discovered in 2007. Objects like this are rare, and astronomers think they are clouds of gas caused by outflows of gas from nearby galaxies. Blasts of ultraviolet and X-ray radiation from a galaxy 200,000 light-years away from the Green Blob are responsible for giving it its emerald glow. The radiation comes from the supermassive black hole, or quasar, at the center of the galaxy. But the black hole at the center of the galaxy IC 2497 is growing slowly and is not producing intense radiation as a quasar. The blob is distant enough from the black hole for the glow to be a delayed response. This means 200,000 years ago the black hole could have been much brighter, and the radiation has taken that long to reach the blob. It used to be assumed this was the reason for the green glow, and that over the next 200,000 years it would become dimmer. But new observations using NASA's Chandra Space Telescope show the black hole is still producing large amounts of energy even though it is no longer generating intense radiation as a quasar. The evidence for this change in the black hole's activity comes from hot gas in the center of IC 2497. The temperature structure in the hot gas suggests the presence of a bubble or cavity around the fading black hole. The researchers, led by Dr. Leah Satori from ETH Zurich, said in a paper. The center of the X-ray emission shows cooler gas, which astronomers say is a large bubble within the hot gas. The bubble may have been created when a pair of jets from the black hole blew away the hot gas. When this happened, the energy produced by the supermassive black hole could have changed from that of a quasar, when energy is given off in a broad beam, to more concentrated output in the form of collimated jets of particles and consistent with the observed radio emission in this source. We conclude that the black hole could inject mechanical energy into the host galaxy at the end of its life cycle, and thus provide a source for mechanical feedback, in a similar way as observed for X-ray binaries, the researchers said. Changes in behavior like this happen in only a few weeks with black holes that are 10 times the mass of the Sun. But in much more massive objects, like the black hole in IC 2497, the change takes thousands of years.